Hi, today we're going to be talking about section 3.3, rules of differentiation. Now, this is one of those tough ones because it's a bunch of rules that you have to memorize. The good news is we'll practice this enough to where it will just become second nature. It'll be really easy to remember with how much practice we'll have here. So I will run through some of these pretty quick and spend time on like the product rule and the quotient rule more than some of the others, because some of the others are just pretty basic and obvious. Number one rule is the derivative of a constant. If we think about the graph here of a constant, let's say we had, let's say our constant here was 2. So the function would be f of x equals 2. Well, remember, derivative is slope. So what is the slope of that line? Well, if you look at the equation there, you know that slope is 0. So it makes sense that if you ever take the derivative of a constant, well, derivative being slope, the slope is 0. Okay? The power rule for positive integers. So if you take the derivative, by the way, if you don't remember, d dx means derivative. So that's just another way of writing derivative. Some people will write derivative as like y prime, right? But d dx is a good way to write it for now. I will abbreviate sometimes. So let's say, for example, we had, what is, if y equals something simple, x cubed, what is the derivative? They might say what? Then y prime equals what? Okay, if we use the power rule here, you take the power, okay, and it goes down in front, so it becomes y prime equals, move that power down in front, 3x, and then we take 1 off the old power. So the old power is 3, 3 minus 1 is 2. So that would be the derivative of x cubed. Okay, so if you think about the x cubed function, all right, we've got this graph here. It looks like that-ish. Okay. Well, the derivative is 3x squared, so if you think about what 3x squared would look like, all right, it will come down pretty steep and then back up here, all right, which makes sense if our slope is really steep here on the cube function, okay, and we're coming up, coming up, coming up, and it flattens out until it finally goes pretty close to 0 when we get there, okay, and then it goes back up to positive again, really steep. So it makes sense there if you kind of think about its graph also. By the way, all of these rules in your book have the proofs with them, so if you're interested in seeing the proof, please feel free. I try not to waste the time with proofs because I just want to be able to use the calculus. The constant multiple rule. Okay, if you have a constant, you can basically take that constant and put it in front. So if you're doing, for example, if we had, what is, if y equals 2, we'll do x cubed again, 2x cubed this time. Okay, what is y prime? Well, you can say that this is the same thing as saying what is 2 times the derivative d dx of just x cubed. Okay, so you can move that constant in front. It really doesn't matter. You'll see I'll do it once with moving the constant and once without. So first, if we were using the power rule like we did just on the previous one, remember we just do 3 moves down in front, so it's 2 times 3 is 6x, and then the power goes down by 1 squared. Here we would go, okay, this equals 2 times, and then we move that 3 down in front, 3, x, and the power goes down. So when you distribute that, you also get 6x squared. So a constant can always get moved in front. It's very simple to do with this one, and it's not really very useful, but it will become something that we really like to do, especially when we have a constant like the number e or pi or things like that that make some of our functions a little nastier looking. If we just remember that is a constant, we can move that in front. Then we don't have to worry about those things like e and pi. The next rule is the sum and difference rule. If you have a function u and you have a function v, and both are differentiable at, they're both differentiable functions, okay, you can take the derivative separately and then add them, or take the derivative separately and subtract them. For example, I'm going to use power rule a lot just because we're going to use it the most. If I had y equals, we'll go with the old x cubed again, but then we had minus 2x squared. Okay, I can say, if it asks what is the derivative, okay, the derivative would be equal to doing dx of x cubed minus dx of 2x squared. So if I did that, it would become, move the 3 in front, 3x, the power goes down by 1, 2, and then minus, okay, just move that power in front if you really want to. I'm not going to this time because it's just as easy not to. 2 times 2 is 4, so I get a 4x, and the power goes down by 1, so to the first power, or just 4x. Okay, so that would be doing those two derivatives separately and just keeping that minus sign in between. Same thing if it was a plus in between. So that's the sum and the difference rule. Okay, again, we're moving kind of quickly through some of these because these are some of the basic ones. The constant multiple rule, sum and the difference rule. Really, that power rule is the only one that that's kind of a little harder and a little weird to get used to. Like I said, we're going to use it so much, and maybe some of you have even seen it before this. Okay, the product rule. All right, the product rule written here, how I think of it is dx, or the derivative of u v, is equal to, I write it like this: first u is the first one, times the derivative of the second, so I do v prime, plus the second term, v, times the derivative of the first. Okay, first times the derivative of the second, plus second times the derivative of the first. That is the product rule. So say it with me. First times the derivative of the second, plus second times the derivative of the first. Seriously, I didn't hear you. Louder. First times the derivative of the second, plus second times the derivative of the first. Okay, hit pause if you need to say it like 10 more times, because that's the product rule, and it's about as simple as that. Okay, I'm assuming you already hit pause now, so good work. I hope you said it like 10 times. For example, if I have two polynomial functions multiplied next to each other, so if I said that f of x equals x squared minus 3x plus 1 times x plus 2. Okay, I could split that into two different functions and say that u equals x squared minus 3x plus 1 and v equals x plus 2. Okay, so then I just go, if it's asking for what is f prime of x, in other words, what's the derivative, or what's the slope function, you might hear it called. Okay, I would say, okay, we would do It's the first, so I just rewrite the first, the u, x squared minus 3x plus 1, first, times the derivative of the second. So I need to find out what is v prime. Well, v prime, okay, if we use the power rule for x has a power of 1, so I bring the 1 down in front, 1, and then I do x to the 0th. Well, anything to the 0th is just 1, so it just becomes x. And then the second part of v is a constant, and we know that the derivative of a constant is 0, so v prime is just 1. So first times the derivative of second, so I could do times 1 here. Really, you don't really need that because times 1, it could just go away. Plus second, so x plus 2, times the derivative of the first. Well, that means we need to calculate u prime. That's u, not a v. Sorry, it's ugly. So u prime equals, use the power rule, 2 comes down in front, the exponent goes down by 1, so 2x minus, okay, the 3 times x is the power of 1, so the 1 comes down, 3 times 1 is just 1, alright, and then x to the 0th is just 1, so it's just 3x, and then a constant 1, remember a derivative of a constant is 0, so the derivative is just 2x minus 3. So I write 2x minus 3, close parentheses. Okay, a lot of times you can just leave it like that. If you want to prove that both of these are correct, go ahead and distribute f of x, and then take the derivative of f of x, and then go ahead and take my derivative I have written here, distribute it, and you should get the same answer. So if you want a little proof of your own there that the product rule works, that's a proof for you. Moving on to the quotient rule. Okay, so the quotient rule, think of two functions being divided. If we look at this the way it's written here, u is the high, the upper one is what I would call high, and v is the lower one, or low. So I'm going to use low and high and low as my two ways of referring to the upper function and the lower function. So the derivative of a quotient, or u over v, is equal to low d high minus high d low over low low. Say it with me. Low d high minus high d low over low low. One more time. Low d high minus high d low over low low. Say it again like 10 times. Hit pause. Say it 10 times. Low d high minus high d low over low low. Okay? Another way you can write it is low is the v, d high minus high d low over low low. Low low means v squared. Low times low. Low low. Okay, low d high minus high d low over low low. I know it sounds weird. Say it a bunch of times. All of a sudden you've got the quotient rule remembered. Now, when I started teaching calculus, or actually really Miss Calamence was still teaching, but I knew I was going to take it over this year, I still remembered the quotient rule back from when I learned it in high school, and that was, I learned it in the year 1999. So, you know, some of you were like 1 or 2 or 0-ish during that time. So that's how long I remembered it. So, you know, 15, 16 years I've held on to the quotient rule using low d high minus high d low over low low. So promise you, if you keep saying that, you will remember it for the next 15 years. I bet you're excited about that. Alright, here's an example. What is the derivative if I say that f of x is equal to x squared plus 2x minus 1 over x plus 3? You would probably want to try to factor this first, but you would realize that, oh darn it, I cannot factor, nothing's going to simplify, so I just need to use the quotient rule to be able to solve this. Okay, what is f prime of x, or what is the derivative of f? Okay, so we just use low, which is x plus 3, d high, so we take the derivative of the high. Okay, so we're calling this u, we're calling this v, so u prime equals, okay, so that becomes 2x plus 2, and then v prime, that's just product rule I'm using, v prime would just be 1. Okay, so low d high is that u prime, so times 2x plus 2 minus high, x squared plus 2x minus 1 times d low, 1, which doesn't need to be there, all over low, x plus 3 squared. That is f prime of x. And for the most part, you just have to leave it like that. Sometimes, obviously, it'll say, what is f prime of 2? So you'd have to plug in a 2 everywhere we had the x's, substitute those in, and find out the slope at an x value of 2. So it might say something like that. Given this function f, what is the slope of this function, the instantaneous slope at 2? Well, we know that the slope is a derivative, so we take the derivative, we plug in 2, and bada bing, bada boom, there you go. Next, we have the power rule for negative integer powers. The only difference between the product rule for these two is we can't take the, if it was just x to the, let's say, first power. No, that would still work. Never mind. So, scratch that. There's no difference. It's the same power rule for negative and positive integer values, so you don't have to worry about it. It's really the exact same thing. Let's try it. If we had, what is, if f of x equals 1 over x squared, what is f prime of x? Well, we could rewrite f of x using a negative exponent to be x to the negative second power. Okay, doing this, then we can just use the power rule, okay, and we know that we bring that power down, okay, so it's negative 2, x to the, you still go down by 1, right, so it's going to be negative 3, because down from negative 2 is negative 3. Okay, and then you might rewrite that f prime of x is equal to negative 2 over x cubed. So that is the negative integer power, or that's just a power rule with a negative power. Like I said, you're following the exact same rule, right? You're just having to, a lot of times, make it a negative integer before you use it. Okay, hopefully even by now you're starting to see and understand the power rule pretty well, just because we've already used it a bunch of times. Higher degree derivatives. Okay, I'm going to do this one and then you'll do the next one. So I want to find the first 4 derivatives of the following function. So first, y prime equals, okay, we bring that 2 down, lower the power by 1. The next one, bring that 1 down and lower the power, just leave us a plus 1, and that 3 gives us a 0. So there's y prime. Next derivative, I just do the derivative of the first derivative function. So again, the power of x is just the first power, so 1 times 2 is just 2. X to the 0th is just 1, so it's just 2. Okay, my third derivative here, okay, derivative of a constant is 0. Okay, my fourth derivative, you'd write it something like this. Okay, with parentheses, so be careful there. So that you know that's not saying y to the fourth, but parentheses around that 4. Okay, this equals, well, 0 is a constant, so it is also equal to 0. Okay, I should have probably chose a different one. Maybe I'll just do one more that's a higher degree. So if we had y equals 3x to the fourth plus 2x squared minus x plus 1, I would say y prime equals 4 times 3 is 12, bring the power down by 1, so that's 3, plus 2 times 2 is 4, bring the power down by 1, negative x just turns into a negative 1, 1, that constant's 0, so there's the first derivative. Second derivative equals 12 times 3 is 36, x goes down by 1 power to x squared, plus, that just becomes 4, and then the minus 1, the derivative of negative 1 is 0. Okay, the third derivative equals 36 times 2 is 72, x, 4 goes away, it's constant. The fourth derivative equals 72. So there's one that doesn't just go to zeros faster, so I just wanted to throw that in. I want you to try, so give this one a shot, and hit pause, go. Okay, hopefully you did 2 times 2 y prime equals 4x minus 5 y double prime equals 4, which means y the third derivative or triple prime equals 0, which means also the fourth derivative is equal to 0. Okay, we are going to practice a lot in class, so just be ready to do lots of practice with these, and we will be ready to rock and roll with some of these first rules of derivatives. These are the first 7 rules. There's about 20 rules that we're going to have to memorize for derivatives. Okay, so these are the first 7. Bring in any questions that you have so that we can go over them in class. Have a fantastic night. Thanks.